Good evening, lovely people. Can you hear me? Can you hear me? Am I coming through loud and clear? Hopefully all my settings are still the same as last time. Fantastic. Right, time to show my ugly face. Okay, is that coming through? Yeah, that's coming through. Greetings all. Thank you for joining in again. My apologies for being a little inconsistent with these streams. Good evening to you, Atwolf, MXDSec, Bandit. Lovely to see your usernames again. Yeah, last few days have been a bit hectic. My wife and eldest son are down in Sydney now. They are at the Australian National Climbing Competition for juniors. So I got to go last year and the missus gets to go this year, which is fair. Me, I'm at home babysitting number 2 son, who is now in bed. And I am sitting here with my black Assam tea with a little bit of milk, because hacking without tea is very uncivilized. I hope you have your teas as well. So yeah, that's I've actually been in Sydney for a couple of days this week, which threw the schedule out as well. Hey Archbishop, how you going, dude? Thanks for coming in. So yeah, it's been a pretty hectic week. Trips down to Sydney, and then early next week or mid next week I'm taking off and heading over to the US for a little while. So that will throw a little spanner in the works as far as streaming schedules is concerned. But we'll do what we can. I'm heading to Austin, Bandit. I'm heading to Austin for the Metasploit hackathon for, I think it's a total of 4 or 5 days. When exactly? I'll be taking off here on the 29th of May, and I'll be leaving, I think, is it on the 3rd of June? 3rd, maybe 4th of June. So I'm not there for long, but if you're there, it would be awesome to catch up. So, bummer. Well. Maybe next time. Had I known, maybe I could have stuck around for a little bit longer, but so hard jamming this stuff into everyone's schedules. But when we are on the same patch of turf and close enough, we will make a point of catching up. Okay, so anyway, let us not dilly-dally. No, I'm not going to Black Hat. Black Hat and DEF CON are not on the cards for me at the moment. I have no desire to go. I'd be going just to catch up with people, and it's a tough expense to justify going to that side of the planet just for that. So we'll just have to play it by ear. Maybe you can come to Australia instead. We're a land of the free. Okay, anyway. So my plan tonight is to go for the full 2 hours. Bash out one this evening and get a good chunk of functionality in. And hopefully, if all goes well, I will do the same again tomorrow. We need more cons. we need more cons. We've got a lot of cons here. It's about getting the right con, maybe the better con or more appropriate con or something similar. Anyway, enough of my face. Thanks again for joining. Let's move over to VMware and pick up from where we left off. So yeah, that's a bit controversial, isn't it? Saying a better con. But anyway, a more appropriate con is probably a better term. So last time on stream, we were at a point where we were able to send and receive packets, I believe. Although we haven't actually generated any responses yet to be able to send back. So that's something that we're going to work on now. So what I should probably do is begin by adding like a catch-all scenario where if a request comes in and we don't have a valid response for it, then we should probably just return like a not implemented error, shall we say. And so before we go ahead and implement a proper command dispatcher, I'm going to add some code here. Hopefully you guys remember this. I'm going to add some code here where if we're unable to invoke a handler for a given incoming request, then we'll generate our own response. So what I'm going to do to begin with is we need to come up with a way of saying, right, let's create an empty response, and we will just basically set the result of that response to some kind of error. Now, in order to do that, we should probably look at an existing implementation to see what they do when there's a packet that comes in that they don't understand. So let's have a quick look at payloads. I'm going to look at the Python one because that's the one that has sort of a catch-all. Let's open this up for a minute. So where are we? I'm just going to quickly scroll to the point where we basically create a response. So you can see here we're going call read, call write. Where are we? There's going to be a lot of references to response here. So we need to basically look for the bit where it's creating a response as part of a default because there was nothing that actually got implemented for that particular dispatcher. So here we go, run. So if we get a request, create a response. If we get a response, then send it. Now we should always get a response, right? So let's see what create response does. So that's just creating a response. Oh, look at that. Oh, this is interesting. By default, we have to add the method TLV, which should go back out. And by the looks of it, we add the UUID to every response. So we're going to have to do that too. So anyway, from here, what we need to do, we can see here, it's looking for any extension function. And if it can find it, then what does it do? Catches exception is result equals error result. So error result not implemented error. So this is the result that's actually returned. So let's see. So before we move on, no, let's go to the definition of this error result. Okay, so what are we doing here? Error result windows. This is interesting. So I'm trying to find out exactly how the error codes are mapped directly to what it is that we're doing. This is obviously a little hash checking thing and says, hey, you know, if we have a Windows error, then use the error number and return that. So I think what we'll probably do is just return error failure, which is defined somewhere. Probably right near the top, yeah. Error failure 1. Not defined in the original C implementation. Okay. So maybe we need to then look at what these things are returning. Maybe we need to look for a not implemented. So perhaps looking at the C code is a better option. But you see, there's none of the C code at this particular point that doesn't actually implement anything. So maybe we could find. So let's do error success. This is going to be all over the place. So we do actually want to return an invalid response. Like we want to say that there's something wrong. Now from memory, looking at the Windows implementation, we just return Win32 error codes all the time. So maybe what we need to look at for error codes, Windows error code not implemented. Let's see what if there is something to do with the system error code. Windows system error code. See if we can find one in here that says effectively not implemented. There we go. Call not implemented. We should probably grab something that defines each one of these at some point, but for now, we may need to just chuck this in the packet itself. So if what we can do is create like an empty response. So say for example, if the response that we get out of the handler is null, then we'll create our own. We'll go response equals request.createResponse. Now response, we need to set the result. Do we have a result? No, we don't. Oops. What was it again? Error call not implemented. So we need to define that somewhere. Have we got like a high level enumeration? I don't think we do. So what I might do is put this inside the body of the packet. So public enum result, and we'll make this a uint32 as well. So we'll try and make them less Windowsy. So it'll be like this. We don't necessarily need to put the word error in front, given that we have a value that we know. Where is it? 120. So that's 120. We know that success is 0. Okay. Everyone still with me? Pretty lean show tonight, but I'm not surprised. It was kind of ad hoc, and as these series tend to go, the longer and longer you go, the less people we have. Barney, you're such a juvenile. I love it. Welcome, mate. I hope you brought your tea. So what we want to have, I don't know whether to call that a I'm not just going to call it a result. I should make it packet specific, right? Result is kind of just the little, actually no, let's leave it as result. No, we'll leave it as we'll call it packet result, because it is actually associated with the packet, right? And so the packet itself needs to have a result, and we'll implement that in a similar way to everything else. So we've got a request ID and a method. Now when we actually, we've got to quickly check something else. When we create a response, we do specify the method and everything too. Okay. Now what we do need to do is wire in the UUID, so we'll figure that out afterwards, but for now that should be enough to get us going. Public packet result. Now when we get this, we're going to do something similar to TLV type result. Value as dword. Now we did have some extensions in here, didn't we? The extensions for enumerations. So that's to MetaType. I was hoping for a nicer extension method. What I should probably just do is go public static t to enum of type t. This, what is it? It's a uint 32 value. Return, we can just do the cast like so, using system. So value as dword dot to enum packet result. I think it just reads a little nicer than doing the cast directly. Yeah? Is it just me, or is your font smaller? No, it is just you, but I can make it bigger if you like. Oh, Will's here. Excellent. Chicken and hacking. You do get my approval for that. Right, so that's getting, but setting is a bit of a different story. So what we need to do is, we know that there should only be one result. So what we should probably do is create another extension method where we can just call like set, and set will make sure that if there is a value in there that we overwrite it. Yeah. So maybe we should do that. This dot TLV type dot result. So that will return a list. Or maybe what we should do is go this dot TLVs dot maybe like set single, or something along those lines. Does this make sense? This is one of those things that's a bit of a shit fight with the abstraction. We know we're going to be setting single values every time. And if the value's there, we kind of want to overwrite it, you know? And we don't want to duplicate that code all over the place. Who's got some serious issues? Killix, welcome by the way. So I'm going to call set TLV type dot result to value. Hey Will, thanks for coming in, buddy. So nice to have you here, mate. So what I'm going to do is I'm going to add a, let's just make sure that we've got here TLV type list of TLV. So we're going to add a new class called, add a new class, and this is going to be pretty specific. We'll call them TLV extensions, even though this isn't specifically attached to a TLV itself. It's more associated with the elements that are around the TLV. So public static class TLV extensions. What we're going to do is we're going to have a public static void, because this function actually modifies state. And see how we've got this set function. So we want to pass in, pardon me, one of these dictionaries. Okay, so that'll be this public void set. Okay, now this will be this, whatever the dictionary is, so TLVs. We're going to be taking a TLV type, right? Type, and we're going to be taking, at least in this case, we know it's an enumeration. We should probably have like a to enumeration. Oh, we've already got a to enum, don't we? Okay, so what I need to do is add an extension that would do this. So that pulls out a value as a D word and we convert that. So we need to basically do the same thing here. Why is this complaining? Can't convert. Where T, would that work? I can't remember the syntax to force it to be of a value type. We'll look into that in just a minute, but we will come back to it. So, right, you know what? For now, I'm just going to cast it to a uint32 directly. Okay. Hey, null mode, thanks for coming in, buddy. Okay, so that means... where are we? uint32 value. So, oops, wrong one. uint32 value. Let's include that. We're going to need our generic collections as well. Okay, so what we want to have is elements, which is going to be, what is it? It's the default list of TLV. So, and then we're going to try and get it out. So if we don't get it out of the dictionary, so TLVs dot try get value, we need to give it the key, which is the type, and we go out elements. So if that doesn't exist, then we need to go elements, we should actually say TLVs type equals elements, which equals a new list of TLV. So let's invert this a little bit. That'll be the else condition. So if we do find it, we're going to go elements.clear and elements.add value. Oh, no, sorry. And new TLV, type and value. Type is TLV type. Oh no, we don't need to do that, do we? We don't need to do that. Oh, my buffering. I got to look at my own API. I can't remember how I We should actually probably not be doing this here. Hey, this is my problem. I'm making it as part of an extension, and I probably shouldn't be doing that. I should be making it on the packet or on the TLV. So we've got things in here that allow us to do that, so that we can add. Maybe what we should do in this case is reuse this functionality and avoid the additional extensions. I think that's probably wise. So let me just quickly renege on what I was going to do. So that's adding values. Maybe I'm actually even over engineering this to begin with, right? Because in fact, I know that I am. So let's just quickly reel back out for a minute. Go back to server. Let me just put this back in for a minute. I'm a little all over the place today. I'm sorry about that. Packet type, packet results. Call not implemented. Okay, so what we should do is instead of not equal null, we need to check if it's null. If it's null, then create a response and set the result to call not implemented, right? And maybe behind the scenes as part of this, instead of trying to be all funky with this, let's do this. We can get rid of those extensions then. And instead of this.tlvs.set, what we might do, for now we're going to assume that the caller knows what they're doing. And we're going to go this.add TLV type dot result. And we're going to just cast this to a uint32 and be done with it. So technically this gives us the ability to add multiple results, which isn't ideal. But what I would like to do afterwards is put some code in place at the packet level and at the TLV level to say I actually just want to set this value, which basically, if it doesn't already exist, contains just the one value. So that would just be adding the value. So what we can probably do is have a function to remove a TLV. And we can basically then call add and remove, and we basically get exactly what we're looking for. But adding a result is clearly important. So once we've got our result, we then send the packet as part of that response, right? But now creating the response is one thing, but what I need to be able to do here before we send it, response.add tlvtype.uuid. We should have a session object, session UUID. Make sure that we send that, remember, because just like what the Python implementation was doing. Where was it? I can't remember. That was in a run function. That's right. We run and we get a create response. And this is where we did it. So remember, we add the UUID every time. So we've got the method. We've got packet type method. And from there, we just return as long as we got the request ID. Okay, so method, UUID, request ID, and result. Now we've already got the request ID in here, so this should actually be fine. Okay, so what will be interesting now is to see what would happen if we end up connecting back to Metasploit and seeing how this functions. So let's launch our listener and we'll go from there. Remember to sing out if you have any questions, guys, because I'm rambling a little bit here and it might not make the most sense. But what I'm trying to do is put in some sensible default behavior so that when we get a packet coming in that doesn't have a handler, we can at least return a result. And the important thing about that is that Metasploit will sit there and hang waiting for a result, right? If it doesn't get a result, it'll just sit there and then eventually time out. So a result with an error is better than no result at all, okay? So let's see what happens here. Let's build. And what I'm going to do is I'm going to put the breakpoint here. Now remember, we've got all the wiring and whatnot ready so that when we build, there should be an active symlink. Let's just check that. Okay, so CDE code, Metasploit framework, data Meterpreter. Cool. Okay, so you can see we actually do a copy to this location on successful build, and we've got a symlink to that location. So that's working as expected. All right, let's see what happens. This should all just carry on like we know it should. So we've got a packet, and that request packet contains core negotiate TLV encryption with a request ID. Result, obviously, we don't have one. So maybe that abstraction isn't useful. I'm thinking maybe it's not. So anyway, let's see. We invoke the handler, in which case we should get null because there is no handler. So we're going to create a result, a response packet. And the response packet has call not implemented as the result type. It's got request ID, method, and result. We're going to add the UUID as well. Okay, and let's see what happens here when we try and send the packet. So we've got a raw packet, 147 bytes. Let's see what happens. Ooh, we've just received another packet. The request packet next is core channel EOF. That's really interesting, isn't it? Exception has been thrown by target of invocation. Now let's just have a look back over in Metasploit land to see what happened. Okay, so you can see we got the sending stage and then it died. I'm just going to run this and let it go. I just want to see what that exception is. Do we end up with like a not implemented exception or something? Let's see. Unexpected MetaType. Okay, so we're obviously not deserializing something correctly by the looks. But let's have a look at exactly which packet it is that dies. So let's go here. So our first request is core negotiate TLV encryption. A second is core machine ID, which is excellent. That's exactly what I wanted to see. Core enum ext command. That's the one that's causing it to fail. Okay, well let's see why that's the case. And I'll explain what each one of these packets is doing, or at least should be doing but isn't. So we create a response and we send the packet back out. Ah, so it's the next one that we're trying to deserialize that's the problem. Okay, so let's see what we've got going on here. Cloned header. Bytes to read. So that's saying 172.191. Oh, I know exactly what's going on. I'm pretty sure I know what's going on, by the way. But let's see what the parsing does. So we XOR all the data and we create a stream, and then we get the type out. And the type is a request, which we would expect. And then we go and add a new TLV. Now, if we look at the length, it's 13. The type is a method. So that's good. That should all be working fine. So this dot value is core load lib. So we're actually, right now what's happening is Metasploit's gone, okay, cool, I'm going to give you standard API. And standard API is currently a native DLL. Okay, so we just need to bear that in mind. So we're going to add that. Let's see which meta type it's not happy about. Length 33, type request ID. The next one, something to do with loading of libraries, I would assume. So clearly that's what's causing us to barf in this particular case, because we don't have a meta type that fits. So if we step in here, oops. See here, this is where it's going to barf. Or is it? No. Meta type is... yeah, it's unknown. Clearly we've missed a meta type, or we don't have the ability to parse it. It's not one that we've actually listed in our enumeration. So what that kind of implies is that we are parsing things incorrectly. Either that, or whatever it is that's being pushed in as part of that value, we are not actually listing correctly in here. We didn't even see the correct type come out, so one would assume that I'm missing something silly in here. Channel file seeking, general base types. I'm pretty certain that there's something in here that I'm missing. So we'll come back to that in just a minute. Anyway, the exciting thing is that we clearly have got some back and forth going on. So Metasploit has gone, okay, well, you're not going to give me encrypted packets, we'll just carry on. Sorry, there's a bit of conversation that I'm not answering. Write a new file, we love your rambles. Thanks, Null Mode. Can you verbose Metasploit side to see the response result in the console? The short answer is no. You actually have to go in and add code to the Metasploit code base and relaunch it to get it to spit the packets out of the console, which is pretty irritating, but it is what it is. Bugs like that are always annoying to debug. Yes, I absolutely agree. So what I'm going to do now is I'm going to go back to here, and where we actually read a packet out, that is where I'm going to say, let's spit the packet out. And I think that is in -I. We're looking for, is it to raw? No. From, is it from raw? No, is it from, I can't remember where it is. Anyway, let's edit lib rex post Meterpreter packet. I think it's packet dispatcher. So packet dispatcher, send packet. So we've got a send and we have a receive. Monitor socket. Here we go. Packet, receive packet. Righto. So we receive the packet on the socket, and once we do that, what do we do with it? We actually add it to the queue. So this packet queue is pulled off and parsed on the fly. So hang on. Let's just make sure that what I want to do is find the exact point where the packet is fully received on the socket, and then we can inspect it. So this just parses the header. I'm pretty sure it doesn't do anything else. Packet dot. Ah, here we go. There it is there. Dispatch inbound packet. Right, so let's go standard error dot puts packet dot inspect. Oh, actually, that's not what we want, is it? It's the outbound packet that we want. So I want to know what's being sent. In fact, you know what? We'll leave this in here as well, but we'll wrap it in some stuff. Received. So we'll just go recv, new line. This will give us the ability to see both. It just gets a little bit noisy, right? So let's go packet.to raw session good. So just before we convert it, we're going to do it here as well. Send. All right. Let's fire up MSF console again. Might maximize that so that we can see it in all its glory. And we'll stop debugging here, because this should at least give us an idea of all of the TLVs that we see going across the wire, and we'll hopefully point out the one that we're missing. Okay. Righto, so this type here, RSA pub key, MetaType method, and this is the next one that's request ID. Man, it's actually doing way more than I thought, but let's go back over here. So we should see, like, we're sending a request with these and receive a response, sending, receive. So that's behaving as expected. I'm just going to keep going now until it crashes, because what we should see here is core loadlib, request ID. So we've got data, library path, flags, and target path. So I don't know what these puppies here are. So clearly these are things that we are not correctly parsing. Okay, so our meta type, we've managed to parse raw and ints and strings, but it looks like we're doing something wrong, because the value that we're actually parsing doesn't look like it's invalid. It's as if method request ID and then data. So just bear with me a second. I'm going to go back into, I'm going to disable all our breakpoints again. Go back to packet, parse. What I want to do is get to the point where that one TLV value is about to be pulled apart, and see why that's what's causing the problem. Because this clearly, we're either like misreading a value, or we are missing a TLV type. But I kind of can't help but think that it's the former based on what we're seeing, right? Oh, why'd I do that? My bad, sorry. Parse. We know it's going to be 3 of these, right? 1, 2, 3, and then we step in. No. Oh, we've got 3 packets before we get there, right? So that's the first packet, second packet, third packet. Okay, yeah. So here's packet 1, 2, 3. Right, let's see what's going on. Type is method. Request ID. Type. Okay, so according to Metasploit, method request ID followed by data, which is of type raw. Now, if we look at this value in hex, what does it look like? 2004001A. So that kind of says, hang on, fire up the watch window. Two zero zero 40. It's as if like it's reading from the wrong spot, right? Because TLV type. The length here is 2A01 blah blah blah. It's like that's wrong. So the length is 172052. That doesn't even say what the length is. Be interesting if it did, hey. MetaType. I think it's probably worth, yeah, it could be a missing type or the wrong type. But I'm thinking what would be really good is to be able to see the lengths of these packets as they come in. So what that means, we need to edit packet.rb, because when we inspect, we want to be able to dump. That just does the name. Does for each TLV. Recursively calls itself. Equals TLV's inspect is t.inspect. Let me just make sure I'm in the right. Okay, here we go. This is the inspection code for what we want to do. So that gets the group. Sorry, that gets the metadata type. So that's what's spat out here. Then we have the value, which is just, you know, a helper. But what we want when we spit the value out is I also want to add the length. Post Meterpreter TLV type equals whatever, followed by a recursive call. So when we get the value, I actually want to put the length just here. So we need to figure that out at this time as well. So where do we get it from? Need a longer USB cable. Yeah, go wireless. Base TLV type, length value. It's actually value length type. So type compressive values. Due value inspect. Is there anything in here that refers to the length already? Oh, val.length. Could that be? Could that be it? No, because I'm pretty sure that it's not getting out exactly. Do you think wireless keyword around? Forgive my meandering a little bit here. I'm just trying to figure out the best way of getting the actual length of the packet spat out, the length of the TLV. We've got type and value. Type value. Checks to see if the TLV's value is equivalent to the value pass. Yeah, okay. To raw. Probably the length we would need to spit out based on the type, right? Yeah, I'm gonna undo that. That's not really gonna help me anyway, right? The only thing that I really care about, I guess, is when things are raw. So bugger it. Actually, let's put that back in. Instead, I'm just gonna go value.length. Clearly it's got a length, so let's just see what that does. Hopefully that will at least spit out something that's useful to us so that we can see whether or not the thing that's being generated at this end that causes the crash it crashed at this end because it's trying to the code that I've just added has broken it. That's pretty funny. So I guess I can't do this. Oh, it's val.length. There we go. I blame all of you for not picking up on my terrible efforts. Oh, you did. Thanks, Bandit. Val.length. Too slow. Here we go. So this request for core load lib, this says length is 55. That can't be right. Oh, yeah, okay, I get it. The reason why is because I'm assuming that val.inspect, value.inspect is what generates just a serialized set of bytes. So you'll get a maximum, I assume, of 55. There you go, look at that. It's topping out at 55. 55. It's definitely bigger than 55. Value. Value could be anything, right? And value returns an instance of 0, yeah. Inspect. Type. Compress. Value. So we set this value based on our current sort of member. Debugging Ruby code, man, I hate it. Just hate it. It's awful. I think I might come back to this, by the way. Yeah. Okay, look, let's regroup. We'll come back to that. We'll leave this as is for now. Okay. I'm just going to leave that as is for now. And what I'm planning on doing instead is just looking to handle the packets that we know we need to handle, just so that we actually make some progress. Okay, so if we look at our server, can you get the packet length instead? Yeah, I could, but I'm really interested in the individual TLV because I know that we've read the method, the request ID, etc., etc. So we were able to read this. Hang on, where is it? This one. So we're able to read method request ID. It's this one here that's failing us. And I'm wondering if it's because we are parsing this incorrectly. So we get to data, which we don't currently support, apparently. Maybe we should just look into that. Have I just got a new follower? Thank you for the follow, Tyler. It's very nice of you. Let's just quickly look at this TLV type thing again. So data, according to this, would you look at this? We got a fat finger. Is that what that's supposed to be? That's really interesting. Okay, so look at that. Length is supposed to be 25. I'm wondering if that's the problem. Let's have a look. Oh, this is not going to work because I don't have a listener. Or is it? Method, request ID. I don't think that's actually the problem, but let's see. Unexpected MetaType. What we could do is convert this to hex. The cheeky way. Oops. In hex. So what do we got here? 2004000. So based on our TLV definitions, what do we got here? Doesn't really say much, does it? I'm actually thinking we're just completely reading from the wrong offset. I think that's actually the problem. But it's kind of hard to say at this point, given that I'm just speculating. 2004. It just, I didn't expect this bit to be set. So it's a very, very large value for a type, right? If we had a look at all of the values that come out, I don't think they are that big. So MetaType string. God. Hang on a second. I'm just going to go and do some investigation for a minute. Didn't I just set a breakpoint that I should land on? Stop. Ah, okay. For some reason, these are not behaving as I want them to behave. Just bear with me while I rebuild and try again. Okay, there we go. Okay. So let's just convert that to uint for a minute. So if that is, let's just see what the data type should actually be, right? MetaType.string. If we went TLV type.data, you see this? See how small it is? Copy. So there you go. It's like it's way off. We're getting like those values look legit. Ah, check that out. We're off by 1, I would assume. Right? Off by 1. Is that what that looks like to you guys as well? This should be 0. Got 4 zeros there. So whatever that... Oh no, we're not off by 1. That doesn't make sense. So according to what we're seeing, we should be getting a TLV type that represents this. And we're getting this, which is clearly incorrect. So I think by the looks of it, we're doing something crazy. Maybe our parser is actually slightly busted, but we'll get back to that in just a minute. So okay, with that in place, let's actually construct something that does the right thing. So for now, I'm not going to look at the TLV negotiation. I'm going to look at the next message that comes in, right? So you can see when we establish a session, the first thing that goes out is a negotiate TLV encryption, and then it says give me the machine ID. Okay, so the machine ID, for those people that don't know, is an identifier that's generated on the target. And that identifier is intended to take some information out of the system and create a value that identifies the system in some kind of hash, so that if you have multiple sessions on the same box, you can kind of identify it. So that's what core machine ID does. So let's implement that. Let's actually get that going. That would be good if we could get to the point where we could implement core machine ID. So what I want to show you before we do that is the current implementation that's in Meterp. So let's go core machine ID. We can see here. Right, so see this? Command request. Now, command request is a macro that says we're handling this command with this function. But importantly, command rec means make sure that you handle that on a different thread. Okay? That's basically what that means. You handle it on a different thread. And we can see, based on other functionality, which I'll show you a little bit later on, that behind the scenes it will actually create a different thread for this function to execute on, and then the result is sort of handled in a slightly different way. Now, for now, we are going to just do things inline just to get things moving. But because you can see here, there's this inline. There's an inline one as well. There's request and response handlers. But the point here is I just wanted you to see that machine ID is not inline. So inline means it's actually done on the server thread. Okay. So let's focus on just getting core machine ID done. Machine ID done. Let's go and look at the body of that function. Right, so what are we doing here? We are calling get system directory. Okay, we get the system directory in here. And then what do? We get the computer name. And we terminate it. What are we doing here? Computer name, max path, computer name size. Oh, okay, right, I see. So we're terminating the system directory at the first backslash. So that'll give us like C colon or D colon or something like that. Then we go get volume information for that drive, which gives us the serial number for the drive as a D word. Then we get the computer name, and then we concatenate. We get the serial number that we got from, where do we get that? From volume information. High word and low word, and the computer name when we create this string out of it. Okay, that doesn't look too bad. Hey, 1-800 get system. I hate you guys. All right, so let's at least try and emulate this behavior. So to begin with, we need to get the system directory. So there's got to be a really easy way of doing this. Look at this, environment.system directory. There's probably other ways of just getting the system drive as well, right? But first of all, what we want to be able to do is declare a handler for, you know, the core machine ID bit, okay? So what I'm going to do here is we want to create something that knows how to handle like the core sessions, just related stuff. Now we may even just bake this into the server, right? Because the server is kind of what's responsible for the core functionality anyway. But I just kind of don't like the idea of leaving the handler in all of the code around the handling of individual functions inside this class. So yeah, ding ding. I'll keep Italians. Yeah, thanks, mate. He's AFK today. So what I'm going to do is I'm going to create a new class. Where am I looking? Add new class, and I'm going to call this the command handler. Public. We will make these internal down the track. But basically what I want to do is I need to be able to say can't remember what our plugin manager code looks like. Let me just see. Register function extension name, which would be like metserve string method blocking function packet handler. So let's do this. We're going to have a public void register. We're going to do the same thing basically as what we would expect a plugin to do, right? We'll have a register and an unregister. So let's just copy this. Now in this case, because we're just doing a core command handler, we don't actually need to be able to do anything special. All we want to do is define our function handlers, right? So our function handler needs to be something that takes a packet and returns a packet. Simple as that, right? So we can go packet, which is part of the proto. And this is going to be core machine ID. And we take a request. Now for now, I'm just going to go return, we're going to go request, var response equals request dot create response, response dot add TLV type dot result, and it's going to be packet result dot success, and then we're going to return the response. I'm going to have to do the same thing here, right? Packet result value uint32. I'm just going to cast it just so that it's sitting there ready to be used. We'll be using that again at another time. Okay, so then as part of registering all of these, what we're going to begin with is go manager.register function. We're going to go private const string. What do we call this again? Is it extension name? Extension name. I'm just going to call this metserve. Actually, you know what? I'm going to leave it as string.empty. I don't really want metserve to appear as a string. Can't make it string.empty, so we'll just do that. Extension name. Now the method we're going to register is core machine ID. Is it blocking? No, it's not blocking. It should be done on a separate thread. And here we're going to go this.core machine ID. Okay, so we've just registered our function, but we actually need to invoke that from the server. Okay, so when we bootstrap all of this wonderful nonsense, before we actually kick everything off, we want to be able to go start by register. Actually, no, we don't. We don't want to do it there. We actually need our own internal private command handler. Now, where is the plugin manager creator? Here we go. This.command handler equals new command handler. Now, what I'm going to do is straight away is register our commands with the plugin manager. So this.command handler.register this.plugin manager. Okay, so that means that our functions are wired in straight away before anything else happens. Okay, so we should see this happen as we kick things off, and so with a bit of luck we should see this thing pop out. Let's do a quick rebuild. Rocket League, that'd be so good. If you guys are keen, I'm keen. Let's see what happens. Okay, so we're registering our functionality, which means inside the plugin manager, we should have a list of handlers. Core machine ID is handled by this thing here. Okay, now there are other things that the plugin manager should do. Now see how we've got this extension functions. I'm going to keep track of that as we add. Now I think what we decided on doing was just having the handlers, and we would generate who handles what and when on the fly, but we'll come back to that another time. Let's just look at making sure that the command handling wiring is actually in as we would expect. Look at that, core machine ID. It's just been invoked. Request. It's core machine ID. That's cool. Through exception, blah, count is 2. Yep. Alright, that's cool. It looks like it was doing exactly what it should be doing. Which is pretty interesting. Let's just have a look, because what I'm going to do is send a hard-coded string back. Oh, we've just scored another follower. Who is that? That is Tilt CS. Thank you for the follow. I very much appreciate that. So what I'm going to do is in this handler, wherever I've put it, we're going to go response.add tlv type.machine ID. I'm just going to hard code it. Just going to build that. Kill off all of the breakpoints that I've spun up. Now the reason I'm doing this is because, remember, we should see it come out here. Right, when we get a response from core machine ID, see here we got the request going up. Hopefully we'll actually see the response contain this is the ID. Okay. Where is it? There it is. This is the ID. Cool. So now all we need to do is actually generate a correct response for this, which actually contains the machine ID, including serial numbers and all of that other nonsense. And then we can go on to do other things as well. Where are we? We are... At least we're making some progress, right? I'm still frustrated as to what that might be, but we will figure that out as well. Okay, so going back to the implementation that's in MetaType as it currently stands, there might actually be a machine ID function in here. Does it do the same thing? I would assume it does. Get volume information. Okay, so I'm jumping around again. Let's go back to the C implementation. Okay. Let's start by getting the system directory, and that's what we use to get the serial number. Okay, so we'll look for the .NET version of .NET. We'll go C# get volume information. There's p invoke. Hopefully we won't have to p invoke, right? It looks like everyone's suggesting that we p invoke. But I don't really want to p invoke. Get volume serial number. Hopefully there is a function in the framework that will allow us to do this without having to p invoke. Ooh. This is a bit more interesting. Looking for first okay, I think you retrieve maybe the hard drive model. The serial number comes in Win32 physical media. Okay, so we can use a searcher and extract it from WMI. That's much more interesting, right? Yeah, wouldn't that be nice? Let's see if there's any other ones. It looks like this gets a serial number here. Management object searcher. All right, well let's have a play with this management object searcher. Okay. So This is going to be a private function. Private, what is it going to be? What does it return? The serial number. We don't even know what type it is. We might just have to enumerate it and see what it does. Let's go private void get serial number. Ignore this for now. Get serial number. Now, management object searcher is part of, which class is it part of? Which system.management. So we need to add a reference, assemblies, system.management. Management object searcher, so we can use that. Now this thing is probably disposable. It's a component which is disposable. So using var searcher equals new management object searcher. Now according to this, now see this is a classic case of where Stack Overflow gives you just enough, but it doesn't say that you should wrap these in using statements, right? Which is exactly what you should do. Yeah, pinvoke is messy and noisy. There are usually better options for it. But I'm really not, I'm not a fan of using it. I think there are usually better ways that don't stand out as much as pinvoking. So I'm going to try and avoid pinvoking as much as possible. Okay. So we're going to WMI this kitty. Select star from Win32 physical media. Now get the hard drive from the collection. Get the hardware serial number. So what I might do is this equals searcher.get. Now we can iterate over these, right? Because that returns, what does it return? A management object collection. Let's see what this thing is. I hate that it's not just an enumerable of something. Oh, it is an I collection, which is at least, and by the looks of it, it's disposable. So does that mean we should dispose of it while we're doing it? I reckon it is. Derives equals searcher.get. It's disposable, so we should dispose of it. I have George, my service dog, with me. OJ, George, give him a squeeze from me. Now, this thing is just a CLR. I think I know what the problem is. Maybe that's the problem. Righto. That's what we want. Filters the elements based on... This is what I want to do. Dot. Oh, come on. I'm trying to use link rather than just for eaching over the top, but I think we're just going to have to for each over the top. Drive in drives. Let's have a look at what's in the environment. System.environment. What was it again? Machine name, process account, system directory. I'm going to split that on a backslash. And then we're going to say, now we know the drive, according to what we were reading on Stack Overflow, we can cast it to a hard drive. Okay, so we could go var hd equals drive as, this is interesting. If we can cast that to a hard drive, can we? I guess not, unless there is a HD collection. Get the hard drive from the collection using the index. Oh, okay. Oh, as you already figured this out from something else. You know what I'm going to do? I'm not going to do that cast. Toot root equals. Just give me a mo. I want to step into this. I need to rebuild first. Yeah, sorry, it has already been answered for you. I haven't been paying attention to chat, my bad. But yeah, we're building a new version of MetaType that runs in just basically on .NET, on the CLR. Now, let's just see. It's interesting, isn't it? Let's have a look at what drive looks like. Okay, so drive. Physical drive 0. Is that the only one? Yep, no. Drive CD-ROM. So there's only 2. We want to get, basically want to get C drive, right? So in order to get that, is that listed here anywhere? Drive is physical drive 0. It doesn't really give you the volume label, does it? So where do we find the volume label? With properties? Yeah, here we go. Capacity. Caption. Trying to find the actual value in here. Class creation name, description. You need to get logical drives. Yeah, that's true actually. Win32. I'm pretty sure it's just logical drives, right? No. Oops. Need to rebuild. Yeah, that's gonna buff. Runtime method, yeah. Is it logical drives? Can anyone remember? WMI logical drives. The thing is, like, as logical disk. No. Logical disk. Win32 logical disk. Let's break here and see what happens. That doesn't work either. What am I doing wrong, guys? It is logical disk, isn't it? There's even disk drive. Win32 disk drive. That gives us the model. Let's just see what this looks like. That breaks too. Hooray. Oops. Let's do the full rebuild thing just in case there's some other shenanigans going down. Okay, so that did work. Okay. That's still giving us like physical drives. I would assume that it's going to be a property. Like some property that we can... Tracks per cylinder, total tracks, total sectors, total heads, system name. Bytes per sector. I'm looking for like D for drive letter. I would have thought caption may well have been it. Like, is it just query select star from Win32 disk drive? Is that the syntax? No. Ugh, I'm so terrible at life. Maybe there is a better way of getting the serial number. Now, actually, you know what I'm going to do? Maybe we put this one on ice, because what I would like to go through in cases where we are going to have to p-invoke, which in this case may actually be the most sensible option, we're actually going to dynamically generate classes that we p-invoke through so that they're not actually fingerprintable up front. And we're going to go through that. Maybe we'll go through that on the next stream. So let's just leave it like this for now. I mean, one thing that we do know that we're going to use is the serial number. And the other thing that we're going to use is the machine name. Okay. So we can go serial number equals, it's going to look something like this. Okay. And then we'll have the machine name, which will be system.environment .machine name. And so the machine ID will be string.format of serial, serial number and machine name. And then we can put this in here. Hopefully that makes sense. Does that make sense? I'm pretty sure it does make sense based on what you guys are seeing. Let's give that another spin. Man, this rebuilding thing is a little bit annoying, but hey. Oh, maybe it did actually work. Yeah, there you go. It did work. We just got to fix that exception. Anyway, we know it's a result. We've got the UUID in there, etc. Why is the primary HTTP used as an identifier? We just had to pick some random stuff. Chances are that it's not going to change over the course of the session, among other things. But yeah, that's basically it. String.format instead of string interpolation. Yeah, so for fixed sized things like this, yes, it is my personal preference to string.format. If you're going to be generating a large amount of string related stuff, you should use a string builder. You could do the, plus, but every time you plus, it's inefficient to use plus. It's more efficient to string format, apparently. That may well have changed. But yeah, at the end of the day, I tend to string.format. Plus, I think it's a bit easier to read. You can see what the format of the string should be like, along with the parameters, rather than trying to sort of visually pull apart a bunch of concatenations. That's just personal preference, really. I don't think in this case it actually matters that much. So, yeah. Hopefully that answers your question. So once we've received core machine ID, we get core enum ext command. Now this is important. Core ext enum command basically says I want you to enumerate extension commands for this extension. So this is Metasploit basically saying, do you have standard API? And if you do, what functions do you have, right? So what we'll do now, in this case, the plugin manager is actually the best / most responsible thing, because the plugin manager is what's tracking the extension commands for a particular extension. Okay, so if you want to get, for example, private list of string, or I should, you know what I'm going to do? I'm going to go private IEnumerable of string. Get commands for extension name. So what we'll do is we'll go if we want to make sure that there are actually values. If this .handlers .contains key extension name, then we're going to do something. Is it break? I think it's yield break. Otherwise, we're just going to go yield break. That basically is the same as returning an empty collection. Okay. So if it does contain that, then basically what we want to do is go this .handlers handlers. We don't give it the key. So the handlers method. Right. So the values where. Let's go where the value, which we know is a function definition, fd.extension name equals ext name. So if the extension name that maps for this function has the function name that we have passed in, then we want to select from that function definition the method, which is the string that identifies it, right? So we can go return. Now why can't we do this? Cannot return a value from an iterator. Use the yield return statement to return a value. Break. Okay, so what we need to do is go for each method in, var method. Yield return method. Okay, so that means we're effectively lazily enumerating these things. And that means that we can actually define, when we create our own, we can have our own custom definitions in here, right? So we've got this get commands for extensions. We want to go public packet, private packet, ext, sorry, let me just quickly check, core enum, whatever that is. Now we're going to try and match it, right? So it's core enum ext cmd packet request. Okay, so now we can go var response equals request.create response. Now we are going to do the same thing as what the other one did, where we're going to add the result. And we will return response. But basically what we need to be able to do is for each one of the results, each one of these commands for extension. So for each var cmd in get commands for extension request dot. Oh, we actually need to get the value out of the TLV. So we go var ext name equals request dot TLVs dot, no, we need TLV type dot, what type is it? Does everyone remember? String. It's just plain old string. That's all it is. So we can see there, it's there for priv, type equals string. So we don't even have anything more than just a plain old string. Come on, talk to me. Yes, string dot first. Dot value as string. So that should give us the word like standard API, right? And then from here we can go ext name. And then we go response.add TLV type. Now we need to know what it's expecting. It could literally just return a string as well, right? So let's have a look at the, let's say the C implementation of core ext enums, oh, sorry, enum ext cmd. Okay, so that does it in here. What type are we actually spitting out? Whoops, wrong one. Oh no, no, that's the right one. So what do? We are just adding strings. So what are we doing? We're creating a response. Extension name packet TLV string, and then we enumerate over it, and the callback is extcmd callback. So it goes over the extensions and it adds a string of plain old, there you go, that's all it is. So it is a string cmd. You gifting subs again, Barney. You're a legend. And yes, I am jumping off at the 2-hour mark, as always. Anyway, so let's just register our own handler for this function. So internal function registrations. Okay, so we want to go this dot register function. I'm just going to leave that blank as well. We'll come back to that later on. Method is going to be core enum ext cmd, and it's this dot. So that should work. Oh, blocking. Is it blocking? That's a good question. Is it block? I don't think it's blocking. I think it's threaded. Record. There you go. Command rec. So it's not blocking. So false. We'll handle the blocking and unblocking, all that sort of stuff another time. But what I want to do is get to the point where this is actually correctly invoked. And we'll see what happens. Okay, so according to this, we are looking for, I've done something wrong. So TLVs, request ID. Oh, what's this? Key value. That's pretty interesting, isn't it? Just give me a sec to make sure that the TLV related shenanigans is correct. So here it's saying that string is of type 11, right? Why is that not the case? Standard API is of type string. Now, according to here, ooh, we've got another fail. MetaType string 10, 11, and 12. String uint bool. If I muff that as well, string needs to be 10. I've done it again. See, this is what happens when you fat finger. Look, I've done the same thing here. Channel ID and channel type are the same. So maybe that needs to be 50. Let's just quickly check. Yeah, it does. It's what happens when you don't check your own work, right? Hey? Hey? Poor form, Reeves. That's better. So, let's see what happens here. So, do we have any handlers? Contains key. Ah, see, that's never going to work, is it? We shouldn't even be checking contains key because the handlers match function names. So we don't need any of this. In other words, we can just do that. So that should end up with an empty list, right? So if we rebuild this, we'll stick a breakpoint here. Actually, you know what? We'll stick a breakpoint here and here. And you'll notice that this first breakpoint won't get set, won't get hit. It'll jump straight to the second one. See? Because there are no extensioned functions registered. Now, what I'm just going to test for the sake of funsies, if we set this to, stop. If we set this instead to standard API, which is certainly not where it belongs, we should see it hit. We should see it hit. So you register that, and then when we get to here, we get one, and that command is core enum.ext command. So that looks like it's behaving as I would expect. Alright, so let's string.empty that puppy there. And what I might do for the command handler in here is get rid of this as well. And we'll just assume that any functions that are part of core just don't have an extension name. We need the subs to get the get system emote. Yes, that's true. Hey, Exorcat's turned up. Thanks for jumping in, mate. 20 minutes left to go. We've got some semblance of some things working along the way, so could be worse. Could be better. I'm a little bit all over the place tonight, which I apologize for. I'm trying to get back into the vibe. But at least we've got the semblance of some kind of command dispatching happening. And so down the track, in the next couple of streams, what we'll probably do is look to implement doing things on threads versus not on threads. And a couple of other things like figuring out why we keep crashing when we're receiving a packet that should appears to work everywhere else but doesn't work here. It's like we're reading the wrong types. Okay, so with that in place, we currently have So as I said, when MSF calls core enum.ext command, it's basically saying, can you please give me the list of functions that are associated with this extension? And that's it saying, hey, do you actually have that extension loaded? If so, which functions are wired in, so that it can do some accounting on the client side. So when you return a response that doesn't have any entries in it, MSF goes, okay, well that tells me that you don't have standard API, which is what this next thing here is doing, right? You see it's pulling this thing off disk and sending the extension down the wire. And as a result of that, you can see we're actually getting the native one out, which is not what we want. But we can fix that. The point that we're trying to make right now is we're reading a binary off disk, we're sending it down the wire, and we're currently mishandling it. So what might be worth doing is taking the first however many bytes off this just as a data stream and dumping that to console. Let's fix this first before we move on. Let's fix this because it is driving me a little bit nuts. So when we inspect, where did I put DER? Here we go. So that's what we're about to send. I'm going to go standard error.puts. No. Let's go into the packet functionality to okay, so this is, there you go. So that's setting it, doing it to raw. And that's doing it to raw, and then here you've got everything else. And then internally you can see it pulls the TLV data out here. Okay, standard error.puts. So this is what we're sending raw. We'll go TLV data inspect. And let's run again. So we should see a bunch of shit appear on screen. Here we go. So that popped. And then over here, hey. Like I said, it's a mess. So this is standard API we're staring at, which is why it's so big. Okay, see that? Now what we're looking for here is a series of bytes that maps to this. Remember that? So we are successfully reading all of this information. We get core load lib out, and there's the null terminator. And then we've got another length of 4 bytes here, followed by another 4 bytes, 1, 2, 3, 4, which is the request ID, right? We can see that this is the type, right? So there's the length, the type, followed by all of that stuff there, null terminated. Okay? Maybe this is the problem. So this ASCII value here. Okay. Let me just go. So as you can see, sorry, I've gone too far. 29. Is that right? Sorry, decimal. It's not 29. It is 41. So 41 characters. So what this is implying here is this is 41 characters long, minus 8, so 33 characters long, because the 8 for the type and the value. So we've got this many, right? let me just jump into Vim. So you can see we are on row 32, which means that's 32 characters long. And that's useful because that says, oh crap. Sorry, let me scroll up. Come on, computer. That means that we've got all of this stuff here, the 0 followed by this null terminator, right? So that's how many bytes we should have read. Okay? But it looks like we may have somehow read another one. Because what we want to capture for the length, for the length value next is this. Those 4 bytes there. But for some reason we're getting, hang on, is that right? 1, 2, 3, 4. Okay, so that is correct. We are reading those 4 bytes. So why is it that we are getting those 4 bytes for the length? And is that length correct? Well, given that it's metserv that it's coughing up, and that's just a little endian integer, we should have these values. Well, let's go back here. I'm open to suggestions if you guys have any. Oh, really? We've got another follower. Copy. Who is that? I've had a YouTube subscriber. And David Traveller has followed as well. Thank you, folks. Very much appreciated. Okay, so in decimal. So 172,060, right, is what it's claiming it needs. So if we go to... Oh, we've got to go to the gem set, don't we? Is it RVM that I got on here? No. RBN. Find name, what's it called? ext server standard API .x86.dll. Okay, so the one that we're running right now, I believe, is this one. Let's have a look at the size of it. That doesn't look right, does it? They're all of a similar size, around 376, 377. So if that's the case, then the value that's appearing here because that's coming straight after method. This is definitely it here, right? 1, 2, 3, 4, and then it should be. Hang on, sorry. 1, 2, 3, 4. 1, 2, 3, 4. So this is really interesting because we should see the MZ header. So maybe that's not the problem. 1, 2, 3, 4 is the type, right? No. Let me take this out for a minute. I'm just going to take the first few bytes. Whoops. Don't you hate that? Control C versus Control Shift C. Let's go back over here. Hello, Evil Enigma. Hello, thank you for coming in. So this is what we got, right? This is the next thing that's being read in. So that right there specifies the length. Am I going mad? 0, 0, 0, 0. Oh no, I don't need the first 0, 0. So, oops. Sorry, got shortcut fat fingering going on here. I think I missed it. Let's take a copy of that. And we will put that in here. Okay, so we get to this section here, right? So that's where our request ID terminates, at that point right there. And we can see that the type is 0001 0002. So I would expect then this to be the length. That's the length. And the type to be 1, 2, 3, 4. This is exactly what we're seeing coming out the other end as well. That makes sense. You see that? We're currently working on figuring out a very small issue with our TLV parser. But what I don't get here is that if we look at this, the first thing we should see is the MZ header, right, for raw. But that's not what we're seeing. So we've got 0400 1A. Where is the MZ header? I can't even see it. I can't see MZ. Can't see it anyway. MZ should be sticking out like the proverbials because we've got MZ 90030004 and I can't see it. Can anyone else see it? I can't see it. It shouldn't be encoded at all. I mean, that's obviously the first thing that you would think, but I don't know. Well, let's have a look at what Meterpreter does. Let's see what the native Meterp does. Request core load lib. Maybe it's compressed. Do you reckon it's compressed? It shouldn't. That's bizarre though. It shouldn't. Let's have a look. So I guess the library path and the flags. It's definitely not on disk. Type data. Get the library's file contents. If the lib does not exist locally, it's being uploaded, which it is because it's local. Get the library's file contents. Type data, data TLV. Get. What? Why is it saying get? Oh, it's getting that and then getting the path. So data TLV. There is nothing special going on here. You can see like it's calling TLV type data, which is raw. Why does that not work? Isn't there an offset where to start from? No, this is just a buffer. As far as the call is concerned, it's just a buffer. Can't the TLV itself have a compressed flag? Yes, but I don't think it's compressed. However, it might be. Let's just check. The thing is, though, that if it was compressed, I would have seen the TLV type come out correctly, right? Because even though we don't currently support compression, we do have that TLV flag. Hang on a minute, I'm just going to get rid of this system management thing. We do have compressed as a type. So we even reference it here. The thing is, we're unable to get the MetaType out because the value that we're actually seeing, the length, this value here, this length value, as we've seen according to the Googles and its hex converter, 2A01C is this. Like what is that? 172060. So I'm confused because we shouldn't be seeing that length for that value anyway. So why is it spitting that out? Am I misreading something? That's definitely standard API and it's definitely pretty big. It doesn't even attempt to load priv because it doesn't get a response. So I don't know. I don't know. No, it shouldn't be encrypted. Plus you can see at the end of this particular packet, you can see this bit's not encrypted. So I don't know, maybe maybe there's something magic going on here that I don't know. But what doesn't make sense to me is like this type is way off anyway. This bit here makes sense to me. 1A. Let's have a quick reverse of that for a minute. Another follower. Domino9. Thank you for the follow. So 1A. That's probably what we should look at to begin with, right? OX1A, 1A in decimal is 26. So if we look for 26 in here, it is raw. Okay, so that's definitely the value that we're looking at, right? Now, according to... It's clearly something that I'm making a mistake on. Because... What am I missing? Let's just go back over here. Okay, so that 04, so that's 20. So if we go OX220 04001A, is it bin? Can we just type bin? There we go. Righto, so that flag, this one here, how many characters is that? Len. Dot, is it split on B? Take the first. Ooh, can't type. 30. So that, if that's the 30th character, then that means it's been shifted how many? 29? So yeah, it is compressed. Ooh, okay, so here's the thing. I'm thinking what we need to do is have a special case here, because what we're saying is that the compression flag can be used in conjunction with the raw flag. So we're seeing here, like, that's the identifier. This bit here says that it's raw, and that bit there says that it's compressed. And that would be why we're getting what we're getting. So that makes perfect sense. So that they do need to be flags. And we need to be smarter in the way that we get our MetaType. So let's take this out for a minute. And then I'm going to go else if MetaType maybe we can go MetaType dot compressed. Oh, I can't type. I have run over time. I have. Just give me 2 more minutes. Thanks, Barney. So what I want to do is, I just want to know if it has the flag on it, right? So if we go to enum extensions, public static bool has flag this dot MetaType. And sorry, yeah, MetaType and MetaType we're going to refer to as I'll just say flag, and then we'll go return MetaType and flag equals flag. I'm sure there's a nicer way of doing this in .NET. Flag attribute .NET C# example. It's just fine. Do not mark enums with flag attributes. Now let's just have a look. Yeah, so it's just doing this. What I'd like to know is, like, does it have that flag set in a nice way? No one's really got it. Has flag. There it is. .NET enum has flag. Why is it that I couldn't see that anywhere? My order dot has flag. Why is that not coming up in IntelliSense? Why am I building a custom version of it? And I knew I'd heard of it somewhere. Okay, so if we go MetaType dot has flag, why can't I see it? We are including system. Don't know why it's not there. Righto, so if it's compressed, maybe add it in a later .NET version. Yeah, I don't know. It's bizarre, isn't it? I thought it was there. Maybe the documentation says which version. Examples, remarks. Applies to .NET Framework, .NET Standard. There you go. .NET 4 is where it appears. That makes so much more sense. Looks like we have to define our own. Okay, so MetaType has flag. Then basically we need to go and pull down whatever it is. Oops. Rebuild. Let's go back over here. Build succeeded. There you go. So the MetaType is definitely raw and compressed. So I had to add those flags so that we could see both. So we need to effectively say, how do we decompress? So that's going to be the topic of the next stream. Okay, so we're going to have to go and figure out how to deal with decompression, which shouldn't be a problem because you know, .NET has deflate and inflate functionality baked into it in some way, so we should be able to implement that pretty quickly depending on stuff. So what can I say? All right, I know I've run slightly over time, which I apologize for, and again, I'm sorry I was a bit rambly tonight. It took me a bit to get back into it, and still kind of is. But we'll regroup again tomorrow, and the plan will be we will focus on getting the decompression stuff working, so that, you know, if something does get sent that's compressed, we can handle that. And I'd like to also revisit a couple of the bits and pieces that we did on the MSF side, because I think we should just remove ourselves from the Windows ecosystem in MSF and just have CLR as the base platform in the same way that Python does. Been thinking about that a lot recently. And then from there we can start implementing more and more commands. I might do a little bit of research off on the side to see what the best way of creating the machine ID is, so that we can, implement that here. And then down the track, I'd say the next steps we'll start to look at is how we can sort of effectively obfuscate p-invoke calls on the fly, and go from there. So, but anyway, I'm really grateful for you all coming along. It is, you know, it's Thursday night. Still got 30, 35 people or so tagging along for the discussion. You were very quiet tonight though, which is cool for me. It means I can just chug on. But, you know, I hope you guys can hit me up with any questions that you may have. And thank you, as always, for providing me with your presence and for listening to me ramble and butcher my code live on stream. Expect it to tidy up over the coming days. It is a little bit messy, but what can you do? All right. Hey, Geckham. Thanks very much, guys. Much appreciated. Have a good night, and I'll look forward to seeing you guys tomorrow. Be good.